Have you ever imagined building a robot capable of moving inside a sphere, balancing itself precisely like a dynamic pendulum? In this video, we present all the steps involved in the fabrication and assembly of our spherical robot. We began with MDF components that had been previously laser cut to form the robot's internal structure. Simultaneously, we started manufacturing the metallic components, the central shaft and the bushings. These parts were machined on a lathe, starting with the facing process to ensure a flat surface perpendicular to the axis of rotation. Central holes were then drilled to hold the parts during machining and to allow for precise diameter reduction. Each component was carefully machined in aluminum and brass. After reaching the desired diameter, we drilled the central hole in the bushings, through which the main shaft would pass. Subsequently, we drilled and tapped lateral holes to allow the bushings to be fastened to other structural parts. All measurements were executed with millimetric precision to ensure proper alignment during assembly and the optimal functioning of the final system. At this stage, the 3D printed parts were also ready. Once received, we refined the holes, adjusting their diameters and tapping threads to allow screws to secure them to the pendulum mechanism. With all parts properly machined and sized, we moved on to preparing the acrylic sphere. Precise markings and symmetrical cuts were made on both sides, allowing for the internal mechanism to be installed. At this point, we also began attaching some components directly to the sphere. After mounting one side, we trimmed the screws to the appropriate length to prevent protrusions that could cause injury or compromise the finish. It is important to emphasize that at every stage, we sanded sharp edges and corners to ensure there were no exposed points that could pose safety risks. All nuts were firmly tightened to ensure secure fastening throughout operation. To fix the central shaft, we used a power drill to create holes in the acrylic sphere, allowing us to install the screws that would hold the bushings in place. With all components ready, we proceeded to the final assembly. This stage was among the most complex, as it required inserting the hand through the cut, opening in the sphere to position and align all the internal mechanisms. Finally, we carefully balanced the internal weights to ensure that the robot remained stable and could move in a straight line without tilting to either side. The robot is operated by an ESP32 microcontroller, which connects to a Wi-Fi network and receives commands directly from an HTML interface specifically developed for this project. This interface enables straightforward and intuitive control of the robot's movement through any standard web browser. All components were carefully assembled within the acrylic sphere. Following a series of tests, the robot was fully operational. This spherical robot represents the culmination of precision machining, digital fabrication, embedded electronics, and significant dedication. It stands as both a considerable technical challenge and a noteworthy accomplishment.
It worked! It worked! I finally invented something that works!